Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers selection. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 6. Beth uses these 4 cards to make 4-digit numbers. How many different 4-digit numbers can she make that are greater than 8,000? Okay, Beth, what are you going to do here? 2, 4, 5 and 8. So we've got 4 places to fill. Let's think about what choices we have for each of these. Now, my number needs to be greater than 8,000. So I don't have a lot of choice for the first digit. It's going to have to be this one here, isn't it? It's going to have to start with an 8. So it's 8,000 and something. If it starts with 2, 4, 5, it's going to be less than 8,000, so it's no good. Okay, so it has to start with the 8s. That was only one choice I had for that. Right, what's the next digit? The next digit could be any of the other 3 numbers. So I've got 3 choices for that one. It could be the 2 or the 4 or the 5. So let's say I pick the 2. How many choices have I got left for the next choice? I've got 2 choices. Let's say I pick the 4. How many choices have I got left for the last one? I've only got 1. Okay, so then we can work out the total number of ways by then multiplying those choices together. So 1 times 3 times 2 times 1 should give me the number of ways of working it out altogether. So 1 times 3 times 2 times 1 is 6. So there are 6 different numbers greater than 8,000 that she can make. Another way of doing it would be an exhaustive approach where you just wrote down all the various values until you had all the different ones. So 8,245, 8,254, etc. Until you got through all of them. Either way, you're going to get 6 values. Question 8. Zoe's password is made up of 4 different digits, and she remembers it as 2 2-digit numbers. The first 2-digit number is a prime number between 10 and 20, and the second 2-digit number is a prime number between 20 and 30. List all her possible passwords. Okay, so we need to know what all the primes are between 10 and 20 and between 20 and 30. So if you remember, prime numbers are numbers that have exactly 2 factors, one in itself. In other words, we don't want to be able to find any other divisors apart from 1 and the number itself. So what are the prime numbers between 1 and 20? Well, 11 is prime, 13 is prime, 15 is not because it's divisible by 3, 17 is prime, and 19 is prime. So we've got 4 possibilities for the first part of her number. Okay, now the second number, what are the prime numbers between 20 and 30? Well, none of the even ones, are they? I'm just checking the odd ones because the only even prime number is 2. So is 21 prime? No, because you can divide it by 3. Is 23 prime? Yeah, I can't think of any numbers that divide into 23. 25 is not prime. Any number divided ending in 5 is divisible by 5. 27, no, that's in the 3 times table. And 29. 29 is prime. There are no other divisors of 29. So I've got 2 primes between 20 and 30, and I've got 4 primes between 10 and 20. So how many different combinations is that then? Well, I could have my 11 and I could have followed by the 23. That would be one combination. I could have the 13 followed by the 23. I could have the 17 followed by the 23. I can have the 19 followed by the 23. So they're all the combinations that end in 23. And also I could have 11 ending in 29. I could have 13 ending in 29. I can have 17 ending in 29, and I can have 19 that ends in 29. So you can see I've got 8 possible passwords that meet those 2 criteria. Also notice I'm going through this systematically, keeping one thing the same and changing the other thing, so I don't miss out any pairs. If you're systematic how you rattle these off, then you're more likely not to miss anything out. Now, when you finish a question, it's always a good idea to just quickly reread it again, make sure you've actually answered everything and given your answer in the correct form. After I'd written my answer down from here, I rescanned it again, and I noticed I'd missed a word out before. It said Zoe's password is made up of 4 different digits. So they've even put that in bold, and I missed it so the first time. So anyway, let's have a look at our numbers again. So we've got 8 possible combinations here. But if our 4 digits need to be different, then I can't have 1, 1, 2, 3 because it's got 2 1s in it. I can't have 1, 3, 2, 3 because it's got 2 3s in it. 1723 is fine, and 1923 is fine. I can't have 1129 though because it's got 2 1s. 1329 is fine. 1729 is fine. But 1929 has got 2 9s, so that one's got to go as well. So my final answer is going to be 1723, 1923, 1329, and 1729. So, moral of the story, always read the question again. Question 9. In a game, 3 stars are hidden at random. Each star is behind a different square on this board. And we've got a grid with 5 by 5 squares, or 25 squares in total. Now we're told that a square is chosen at random. What is the probability that the star is behind it? Okay, so like I say, there are 25 squares in total, and the answer, or the stars, are going to be behind 3 of them. Now you should know that probability is defined as being successful outcomes divided by total outcomes. Now in this case there are 25 outcomes in total that you could pick. You can pick any one of those 25 squares, and 3 of those would be winning squares. So the probability that there's a star behind it is just simply 3 out of 25. Now in part B it says in one game the stars behind 3. In one game the stars are behind 3 consecutive squares. The squares are in one row or in one column. One of the squares is in E2. Write down all the possible pairs of the other 2 squares. Okay, so we know that there's one star in E2. Okay, so there's definitely one there. Now, if they're in consecutive, that means they're all in a row. So they could be there, like that. So that's one possibility. So they could be in C2 and D2. Or they might be this way. In which case they would be in E3 and E4. Now they could also, I suppose, be like that, couldn't they? So they could be in E1 and E3. And I think that's the only other possibility, isn't there? That's the 3 different possibilities that they can be. So let's just write all those down in the answer box. So what do we need to write down? Write down all the possible pairs of the other 2 squares. So we said that it was C2, D2. So it can be C2 and D2. Let's put a plus for them because it's both of those 2. That's the pair. Or maybe you can put them in brackets, that might be better. So if I write them down, C2 comma D2 is one pair. And then my next pair is E3, E4. E3 comma E4. And my last possibility was E1 and E3. Gina makes a sandwich using bread or a roll and ham or cheese and salad or pickle. List all the possible types of sandwich Gina could make. One has been done for you. So it's written down BHS, which stands for that she had it on bread, she had ham in it, and she had salad. Okay, so we need to come up with all the other possibilities. Now I tried to do these systematically, so you keep as much the same and kind of go through it in an ordered way. So let's keep the first two letters the same first off and then switch the last one. So we could have bread, ham, but instead of salad we're going to have pickle. Okay, now I'm going to try and keep bread the same as long as possible. So I've done all the options with ham now. So let's switch ham out to cheese. Now I can have bread, cheese and salad, or I can have bread, cheese and pickle. Okay, so that's all my bready, cheesy options. And I think that's all the ones that I can have with bread, isn't it? Because I've got bread and ham and cheese, bread and ham. So let's switch to rolls this time, and we're going to have pretty much the same methods. So we're going to start with roll and ham and salad, and then I can have roll and ham and pickles, and then I can have roll and cheese and salad, and then I can have roll and cheese and pickle. Okay, so because I've gone through this in an ordered way, I'm pretty confident that I've got through all the list, and you can see there are 8 different possible sandwiches then you can make with these different pairs of ingredients. So what fraction of the possible types of sandwiches have cheese and pickle? So let's go back to our list. You can see that this one has got cheese and pickle in, and this one has cheese and pickle in. So that is 2 sandwiches out of 8 sandwiches then. So the fraction of possible sandwiches that have cheese and pickle are 2 out of 8. Now you could simplify that down to 1/4, but you're not going to get any extra credit if you do or you don't. So either of those answers is acceptable. Question 11. Nick has a 6-digit code. He remembers it as 3 2-digit numbers. Now the first number is between 10 and 20. The second number is 3 times the first number, and the third number is 5 times the first number. All 6 digits are different. Work out the code. Oh, this is a bit of a crazy fun question. And I think it's going to take a little bit of trial and error in order to work it out. Okay, I'm going to be systematic about it. Now, the first number is between 10 and 20. So I'm going to write down my possible first numbers and then work out what my second numbers would be, and then work out what my third number would be, depending on what I pick for the first number, until I get one that I can match all 3. So the first number between 10 and 20 is 11. Okay, now immediately I'm going to rule 11 out because all 6 digits are different. So it isn't 11, is it? Because 1 matches with 1. So it isn't 11. Let's go on to 12. 12. So if the first number is 12, then the second number is 3 times the first number. 3 12s are 36, and the third number is 5 times the first number. So the third number is 5 times the first number. 5 12s are 60. Okay, so here we've got a 6 and a 6, so that isn't working as well. They're not all different digits. Okay, so let's try the next one. 13. So if the first number was 13, then the second number would be 3 times as much. 3 times 13 is 39. No, again, no good. 3 and 3, so that isn't going to work. Let's try 14. 14. 3 14s are 3 10s are 30, 3 4s are 12, so that's 42. So no, another bust. 4 and 4, can't have that. Let's try 5. 15, sorry. 15. 15 times 3 is 45. Oh no, not doing very well here. Another bust. 16. Should have started at the other end. 16. 16 times 3 is 48. Oh, we managed to get past the first one this time. And then 5 times 16. 5 16s are 80. No, again, that isn't working. I've got an 8 and an 8. 17. 17 times 3 is 30, 51. Okay, and again, that one's no good because I've got a 1 and a 1. Let's try 18. 18 times 3 is 30, 54. Okay, so I made it past the first one. And then the next one then will be 18 times 5, which is 90. Right. Okay, I think finally we've cracked it then, haven't we? We've got 6 different digits, which are all different. Okay, so the code is going to be 1854990. Question 8. Jim has 6 banknotes. The value of each note is £5 or £10 or £20. He can make £20 with 3 notes. He can make £55 with 4 notes. He cannot make £25 with 3 notes. He cannot make £25 with 4 notes. List the 6 notes. Okay, so he can make £20 with 3 notes. So if it was, how can you make £20 with 3 notes? Well, you can make it if you've got a £5, a £5, and a £10. Are there any other ways of doing it? No, I don't think so. I just think that's the only way you can make £20, isn't it? With 2 £5 and a £10, that's the only way of doing it with 3 notes. Okay, let's have a look at the next one. He can make £55 with 4 notes. Okay, how many different ways of there of doing that? So let's think about this. If I had 2 £20 notes, then I'd have to make £15 with 2 notes, which I can do. That works. So I can use a £5, a £10, a £20, and a £20. Is there any other way of doing it with 4 notes? I don't think there is. I think that's the only way of doing it. So that combination must be possible. So looking at these two together, then if I can make £20 with a £5, £5, and £10, I must have at least 2 £5 notes. And if I can make £55 with 4 notes, which is a £5, £10, £20, £20, I must have at least 2 £20 notes. Plus, I must have at least 1 £10 note. So I reckon I know 5 out of my 6 notes now. I'm definitely going to have a £5, a £5, a £10, a £20, and a £20. I just don't know what other one I can have. Let's have a look at these last 2 expressions. He cannot make £25 with 3 notes. Cannot make it. So given that I've got 2 5s, a 10, and a 2 20s plus 1 other note. Okay, so I've got a 5, a 5, a 10, a 20, a 20, and a mystery note. Okay, now I can't make £25 with my notes, with 3 of my notes. So if I had £10, £5, that means I can't have another £10 then, doesn't it? Because if I did have another £10, then I could have a £10, a £10, and a £5, making £25. So my last note there, my mystery note, is not a 10, which means it's either a 5 or a 20 then, isn't it? So he cannot make £25 with 4 notes. Cannot make £25 with 4 notes. Okay, so if I used these three, 5, 5 and 10, that adds up to 20. Then if I had another £5, I could make £25 with 4 notes. But if I cannot, then it can't be that one either, which means my last remaining note must be a 20. In which case then I've got 2 5s, 1 10 and 3 20s. That must be the only way I can do it. So 5, 5, 10, 20, 20, 20 is the only way I can meet all of those conditions. Question 9. A music app has a shuffle play function. This means that songs are played in a random order without repeat. Ruth plays 10 songs on shuffle play. One of them is her favourite song. Write down the probability that her favourite song plays first. Okay, so probability is defined to be successful outcomes divided by total outcomes, isn't it? Now, if I'm picking a song at random from 10 songs, then my total outcomes is going to be 10, isn't it? Now, she's only got one favourite song, so for this to be successful, we need to pick her one favourite song out of the 10 songs. So the probability that it picks her favourite song first, is going to be 1 out of 10. Okay, 9b. Ted puts songs A, B and C on shuffle play. List all the possible orders of song A, B and C. The one has been done for you. So we could start with A and then we could have B and then C. I like to try and keep as many things the same as possible. So let's leave the A there. Then I could have a different combination if I had C then followed by B. So ABC is one way and ACB is another. Now what happens if we start with B? I could have B then followed by A and then followed by C, or I could have B followed by C followed by A. They're all the outcomes starting with B. So then let's try C. If I start with C, then I could have A next and then B, or if I start with C, I could have B and then A. So altogether I've got 1, 2, 3, 4, 5, 6 different orders I could play those 3 songs in. Question 14. A menu has a choice of 3 starters, 5 main courses and 4 desserts. How many different choices of a 3-course meal are possible? Well, the number of choices is for each of your 3 starters. You then have 5 choices and then 4 choices. So the total number of choices you get by multiplying those together. 3 times 5 times 4 is 60. So it's that one. Question 21. Lucy makes 5-digit number cards using all of these cards. 3, 4, 6, 7 and 9. So how many different numbers greater than 50,000 can she make? Okay. So let's consider her choices. If she's going to make numbers bigger than 50,000, then there's a restriction on her first selection of her first digit card. She can only pick one of these 3 to start off with then. So she's got 3 choices for her first selection. For her second selection, doesn't matter which one of those 6, 7 or 9 she picks, she'll have 4 other choices for her next digit number. Then she'll have 3 choices for her next digit and 2 and then 1. So the total number of selections that she's got is going to be 3 times 4 times 3 times 2 times 1, which is 72 choices. Question 19. Tom picks a 3-digit even number. The first digit is greater than 6, the second digit is less than 7. How many different numbers could he pick? Okay, so let's think this through. So if the first digit is greater than 6, it could be a 7 or an 8 or a 9. So I've got 3 choices. Okay, if the second digit is less than 7, then it could be a 0, a 1, a 2, a 3, a 4, a 5, or a 6, which is 7 choices. And finally, the last digit, which has got to be an even number, so it can be a 0, a 2, a 4, a 6, or an 8. So that's 5 choices. So the number of different numbers he can pick is going to be those 3 numbers multiplied together. So number of different numbers is going to be 3 times 7 times 5, which is 3 times 7 times 5. It's 105 different numbers he can pick. Question 15. A meal deal is choose 1 sandwich, 1 drink and 1 snack, and there are 7 different sandwiches, 5 different drinks and 3 different snacks. How many different meal deal combinations are there? Well, you can work out the total number of combinations by taking the number of sandwiches and multiplying it by the number of choices of drinks and multiplying that by the number of choices of snacks. So 5 times 3 times 7, 7 5s are, what's that, 35 times 3, 105. So it's going to be 105 different combinations. 15b says 2 of the sandwiches have cheese in them and 3 of the drinks are fizzy. Either picks a meal deal at random, work out the probability that the sandwiches have cheese in it and the drink is fizzy. Give your answer as a fraction. Okay, well, the number of combinations then that have cheese in it and are fizzy, well, how many different choices has she got for those? So here, the number of choices is going to be, well, she's got 2 types of sandwich to pick from. She's got 3 types of drink, which are fizzy, but she's also got some snacks, which there aren't any restrictions on, but she can have any 3 of those snacks. She's going to have to multiply that by another 3. So 2 times 3 times 3 is 18. So she's got 18 different choices for her meal deal if it's going to be cheese and fizzy. So then the probability that she would have picked that then is going to be successful outcomes, number of choices that end up with cheese and fizzy, divided by the total outcomes, which we worked out a second ago was 105. So probability then is going to be 18 over 105. Okay, that's it. Done. Okay, question 14 says A, B and C are different prime numbers less than 20. And we're told that A equals the square root of 4B plus C. Work out 2 possible sets of values of A, B and C. Okay, so we've got some puzzle pieces that we need to fit together in a certain way. Let's first write down what all the primes are between, well, less than 20. So the smallest prime number is 2. Then 3, 5, 7, not 9, 11, 13, not 15, 17, and 19. So I've got 1, 2, 3, 4, 5, 6, 7, 8 to choose from. So these are my primes. Now, I need to then pick 3 of these so they fit into that expression. A equals 4B plus C all square rooted. And that's going to have to give me another prime. Now, there are lots of possible combinations of 3 things from 8 things. So let's just see if we can think it through a little bit and make the choices a little bit easier for us. Now, we're going to have to take the value of B and times it by 4. So I imagine we're going to have to pick our values of B from the kind of lower end of the group. Otherwise, if we multiply them, 17 or 19 by 4, our number's going to get too big, I think. So I'm going to try picking my numbers from B at this end. Now, once we multiply it by 4 and add on C, we're square rooting. So we're aiming to get a square number, aren't we? We can pick a value of b, times it by 4 and add on one of the other numbers, and we're aiming to get a square number. So what are the square numbers? So squares, so we're aiming for 1 or 4 or 9 or 16 or 25 or 36 or 49 and so on. Remember though that a needs to be a prime number too, so I can't just have any square, it has to be a square of a prime number. So not that one. 2 squared is, yeah, 3 squared, 4 squared, not that one. 5 squared is okay, 6 squared, not that one, 7 squared. 9 squared wouldn't be, the next one would be 121 if we're going to get that big. Okay, so let's try a small value of b to start with. Let's try b is 2. So 4 lots of 2 is 8. Now can we pick another prime number to add to 8 in order to get one of our squares that we're looking for? Okay, so let's go through. 8 plus 3 would be 11. No. 8 plus 5 would be 13. That doesn't work. 8 plus 7 is 15. Nope. 8 plus 11 is 19. 8 plus 13 is 21. 8 plus 17 is 25. Now that is one of our options. So 8 plus 17 is 25. And that would be, when I square root it, 25 square root would be 5. So that's one possible solution, isn't it? So that's b is equal to 2, c was equal to 17, and a is 5. So let's write that one in. Set 1, a is 5, b is 2, c is 17. Okay, so we've got one set done. Need to try it again and find another set. So let's try the next possible number. So try b is, let's try another small b. Let's try 3. So again, 4 lots of 3 would be 12. Now can I add another prime number on to get one of my square target ones that I'm looking for? So add in 2 would be 14. That doesn't work. Add in 5 would be 17. That doesn't work. Add in 7 would be 19. Nope. Add in 11 would be 23. Add in 13, that'd be 25 again, wouldn't it? So 4 times 3 plus 13 is 12 plus 13 is 15, is 25 again, and square root of that is 5. So again here b is 3, c is 13, making a 5. Now it doesn't matter that I'm repeating a twice, so these are still 2 sets of results. So a is 5, b is 3, c is 13. Question 5. A code has 4 digits. Each digit is a number from 0 to 9. Digits may be repeated, and the code starts at 5, 4, 1, and there's another digit we don't yet know. Question 5a says, Amy knows that the last digit is odd, but not a 7. She chooses a different odd number at random. What is the probability that she chooses the correct number? Okay, well, we know that probability is equal to successful outcomes over total outcomes. Now in this case she knows that the last digit is a odd number. The odd numbers are 1, 3, 5, 7, 9, but she already knows it's not a 7, so she's not going to randomly pick 7. She's going to randomly pick from 1, 3, 5 and 9. So she's got 4 possible outcomes, only one of which is going to unlock the door, so her probability of success is 1 out of 4, 1/4. Okay, the 4-digit code is changed to be an even number. The first digit is 3. How many possible codes are there? So we're going to have 3 something something something. Now when you're doing a number of ways of counting things like this, it's always good to start with the one that you have restrictions on. So you've got a free choice for your middle two numbers, but the last number there is restricted. This one has to be an even number, so you've only got the choices of 0, 2, 4, 6 and 8 for this one. We know what the first number is, so we've got 1, 2, 3, 4, 5 choices for the first digit. Now for the other two digits we have 10 choices. We've got the numbers from 0 to 9. There's no other restrictions on those, so that's going to be 10 for the second number and 10 for the third number, giving me a total number of possibilities of 5 times 10 times 10, which is 500. So my answer is 500. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.